two particles of equal mass attached by a taut inextensible string of length 2y rest on a horizontal circular table. The particles are respectively y and 3y from the center, so that the center and the particles are collinear. Just out of interest, which one do you think exhibits the greater force on it? The outside one. Think of spinning a weight at the end of a short string, then extend that string even longer and start circling around. It'll take more power and effort to extend the longer radius. This is very evident in Fc equals mr omega squared, where your central pedal force is directly proportional to your radius. Okay? So, bottom line is the outside one is going to pull on the inside one because it's experiencing the greater force. It's more likely to overcome friction, isn't it? Because it has a bigger R value, which means it's going to be more likely to break the the coefficient of friction, because only friction is holding that in place at the moment, okay? And then one of them's going to start pulling on the other one. It's going to be the outside one that pulls on the inside one, okay? Because they're both going to get flung outwards when the friction can no longer hold. Okay, so what we're going to do is we're going to start off with a linear diagram. So what I'm going to do is just draw something like this. Center the circle C. We'll call this the first particle here. So it has a R value because it's mg going directly down. Then we have another one that goes mg directly down, the R value up there. Okay. Now, what happens next, guys, is that the tension is pulling this one inwards, but it's going to be pulling the other one outwards. Remember, it's the tension is only attached between the two particles. There's no rope here. Okay, so the rope is, or the inextensible string is between the two particles. Okay. So we have a coefficient of friction. So friction always opposes the motion. Friction, so phi equals mu r. So in this case, mu is, anybody? Does it say there y over 2? Yeah. So it's going to be y r over 2. So we have y r over 2. And then for this one, we also have y r over 2. Friction opposing the motion both times. Okay, so for the left hand particle, we'll call them particle A and particle B. So I'll call this one A, and this one in here B. Okay, so particle A, same rules apply. Forces up versus forces down. Forces Fc equals mr omega squared. So Fc equals mr omega squared. Okay, so let's begin. F up equals F down. What do we get up from F up equals F down? Anybody? F up equals F down for particle A? R equals mg. Okay, what goes up on particle A equals what goes down on particle A. Okay, what about what's next? What about Fc? Equals mr omega squared. Why are you going to do that? So what's driving it to the right? What's driving particle A to the right? yr over 2. And what else? Tension. T plus yr over 2. Okay, and that will equal m. What's our radius? This one is 3y away because it's y plus 2y gives me 3y. And then simply omega squared. Okay, so that's that one there. Okay, so we're just going to fix that up, and we're going to get t plus yr over 2 equals 3 my omega squared. So we have there is two equations for the particle A. Now I'm going to go for particle B, from particle B's perspective, okay? So let's start with forces up equals forces down. So particle B's perspective, guys, same deal. R equals mg. Nothing new there, okay? So I already have it over the other side, so I don't need it again. Next, I'm going to use Fc equals mr omega squared. So what's driving the particle B to the right? YR over 2. Anything driving it to the left? Minus tension. What will that equal? M, and radius is y, and this is omega squared. Are the omega squareds the same in both cases? Or they are. Can anybody tell me why? Collinear is the best word to use there. They're same angle. So if you imagine that this here is fixed. So one of them's particle 1 and the outside one is particle 2. When I rotate this, oh, can I actually, am I going to rotate this? Oh, here. That would have made sense, thank you. Not the way I want to rotate it, to be honest. But you get that when it does rotate. So basically, when they both undergo the same angle as each other. The angular speed is the same. They both change by the same amount of angle per unit time. Not the same amount of distance, because both arc lengths are different. So the speeds, the linear speeds are different for the two particles, but the angular speeds are identical for both particles, because as you said, they're collinear. They're changing the same amount of angle per unit time. So as I said, just to beat this point home, they're both red dots at A and B, and then they move to C and D in the same unit of time. So they've crossed the same angle. They've undergone the same angular change, hence same angular speed. Hence omega squared is the same. I'll stop using the word hence. Now, get out of there. Yeah, that didn't go too well. Now, so there we are there. Now we have three equations. My suggestion for both equations is to get rid of the r's. So I have equation A, equation B over here, and equation C. So let's just sub in the r's and get rid of the r's, okay? So T plus ymg all over 2 equals 3y omega squared. Okay, I can divide both sides by, what am I trying to find here? Calculate omega. Okay, so that's the interesting part. Okay, then on this one, I'm going to have a ymg over 2 minus t equals my omega squared. What I'm going to do is I'm going to isolate t on both of them. So t equals 3my omega squared minus mymg over 2. This one here, bring the t to the right and this other stuff to the left. Ymg over 2 minus my omega squared equals t. Finally, put both equations equal to each other. 3my omega squared minus ymg over 2 equals ymg over 2 minus my omega squared. Bring the my omega squared to the left, the ymg over 2 to the right. I'm going to get 4my omega squared, and then they're going to add together to give you this ymg, because it's going to be ymg over 2 plus ymg over 2, which in turn does basically means get rid of the half. It's like a half plus a half equals the whole. Now, the m's can go on a hike, the y's can go on a hike, and we're just going to end up with 4w squared equals g. Bring down the 4, square root it, otherwise known as root g over 2. Okay, question 11 done.